Okay, Assalamualaikum. I am Nuri Fanisa and I'm going to explain about linear demand supply functions and changes in demand and supply. So, first thing first is about equilibrium price and quantity. Equilibrium price and quantity. The market equilibrium is the point where demand equals supplies, QD equals QS. QD equal 100, QD equal 100 minus 2P, QS equals 20 plus 3P. Set the QD equals QS 100 minus 2P equals 20 plus 3P. 100 negative 100 100 minus 2P equals 3P multiple 2P 100 minus 20 equal 5P and 80 equals 5P and P we got 16. Next, substitute the P equals 16 into either the demand or supply equation to find Q. QD equal 100 minus 2 multiple by 16 and we got 68. Q for QS equals 20 plus 3 equal plus 3 multiple by 16 and we got 68 too. Thus the equilibrium price is P equals 16 and the equilibrium quantity is Q equal 68. The demand equation is QD equal 100 minus 2P and the supply equation is QS the supply equation is QS equal 20 plus 3P. Next, for the changes in demand and supply. First, new supply equation. The subsidy changes the supply equation to QS equal 30 plus 3P and find the new equilibrium where QD equal QS, which is 100 minus 2P equal 30 plus 3P 100 and 100 minus 30 and we got 5P and we got P for 40. Next, substitute the P equal 14 into the demand or new supply equation to find Q, which is QD equal 100 minus 2 multiply 14 equals 72. QS equal 30 plus 3 multiply the 14 and we got 72. The new equilibrium price is P uh, equals 14 and the new equilibrium quantity is Q equals 72. Next, this is the graph where the demand and supply function. So the graph illustrates the demand and supply function. The blue line represents the demand function QD equal 100 minus 2P. The green line represents the initial supply function QS minus 20 plus 3P and the orange dashed line represents the new supply function after the subsidy QS equal to T plus 3P. The key point here is the original equilibrium is marked in red at P equals 16 and Q equals 68. And the next one is the new equilibrium after the subsidy is marked in purple at P equal 14 and Q equal 72. Okay, that's all. Thank you.
Hi, my name is Nur Afini binti Afendi. I'm from BTPD Sem 1. So here is my part 3, market equilibrium and break-even analysis. So I have two, this part is have two questions. Is question 5 and question 6. Question 5 is market equilibrium analysis. Question 6 is break-even analysis. So here is question 5, market equilibrium. The question is for a different product, the demand and supply functions are given as QD equal to 120 minus 4P and QS equal to 40 plus 2P. So calculate the equilibrium price and quantity. Discuss how shifts in demand or supply. So demand function is QD equal to 120 minus 4P. Supply function is QS equal to 40 plus 2P. So first is find equilibrium price in bracket P. So 120 minus 4P equal to 40 plus 2P. So 120 minus 40 equal 4P plus 2P. So the answer is 80 equal 6P. So 80 divided 6P, so equal to 13.33. So that we find price is 13.33. Okay, number 2 is find equilibrium quantity in bracket Q. So firstly, we have to substitute P is 13.33. 13.33 into either equation. So using QD equal 120.4 in bracket 13.33. So the answer is 100 to 120 minus 53.33 equal to 66.67. So here we have six. The answer is 6.67 units. So the price is 13.33 ringgit Malaysia, and that's for P. And Q quantity is 66.67 units. Okay, here we go with question 6, break-even analysis. The question is, a start-up company incurs a fixed cost of 10,000 ringgit Malaysia and a variable cost of 20 ringgit per unit. It sells the product for 50 per unit. So determine the break-even points. In bracket is unit and revenue. Discuss the significance of the break-even analysis for business discussions making. So the questions given fixed cost is 10,000 and variable cost per unit is 20 and selling price per unit is 50. So the set is BEP equal to FC divided in bracket SP minus VC. So 10,000 divide in bracket 50 minus 20. So we should do 10,000 divide 33. So the answer is 330.3. So the final answer is 334 units. Okay, point 2 is we have to find revenue. So BEP revenue equal to unit multiply SP. So 334 multiply 50. So equal to um, 16,700. So here is revenue is 60,700. That's all for me. Thank you.
Today, I will discuss how to solve an optimization problem in the context of profit function for a manufacturer. The function involves determining the number of units that measure, maximize the profit and calculating the maximum profit. Number one is determining the number of units to maximize profit. Here, the profit function is given as P bracket x bracket equal minus 5x power of 2 plus 115 x minus 500. Here, x represents the number of units sold. To find the number of units that maximize the profit, I need to find the vertex of the parabola. Since the parabola opens downwards, the covariance of x power of 2 is negative. So for the solutions, the formula to find the x coordinate of the vertex is x equal minus b over 2a. And we substitute into the formula, and we must have this. So the profit is maximized when x equal 5 units are sold. Number 2, calculate the maximum profit. Now, now that I know the number of units that maximize profit, I substitute x equal 15 into the profit function to calculate the maximum profit. And from this, P bracket 15 bracket equal 50 equal minus 5 bracket 15 bracket a, my, a power of 2 plus 115 equal 15 bracket minus 500. And from this, we calculate with calculator, then the answer is this. Then after that, we calculate all, then we must have this answer. From that, I know that the maximum profit is RM 625. And then for the chart, illustrate the profit function graphically. And this is the graph that I make for to visually these functions. I can plot this profit function graph. The graph is a downgrade opening parabola with the maximum points at x equal 15 and p bracket 15 bracket equal 625. The maximum point indicate the number of units where the profit is the highest at this point. And then that's all for me.
Okay, so my name is Siti Zulaika binti Ramli and I'm from BTPD SEM 1. So for the question part 2, which is cost and revenue function. Question 3 is a linear and cost revenue. The question that already given is a company cost function is cost function equal 50x plus 500 and its revenue function is revenue function equal 80x where x is the number of unit produced and sold. So we need to determine the break-even point, which is unit and revenue. And we also plot the cost and revenue function on the same graph. So for the solution, we substitute the cost function and revenue function into break-even point formula, which is cost function equal to revenue function. So we have 50x plus 500 equal to 80x. So 500 equal 80x minus 50x. 500 equal to 30x. 500 over 30 equal x, and the answer is 16.67. So here the answer for unit that must sold. So we substitute the unit that must sold into the revenue function and cost function, and we have answer is 1,333.6. So here the break even point. So for plot the graph, we choose y-intercept when x equal to 0 and x equal to 30. So we have 0 and 2,400 for y. Next, y-intercept when x equal to 0, we have y equal to 500, and y-intercept when x equal to 30, we have y equal to 2,000. So here the graph that I already plot, we have x as a number of units sold and y as cost and revenue. We have straight line for revenue function equal to 18x, and another line for cost function equal 50x plus 500, and we have intersection point here. So for next question is question 4, which is quadratic revenue. So for next question is question 4, the question is if the revenue function changes to revenue function equal to negative 2x squared plus 50x. Find the maximum revenue and the number of units that must be sold to achieve it, and graph the revenue function and indicate the maximum point. Okay, so based on the question given, we have a revenue function negative 2x squared plus 80x. So we have A, B, and C, and A is less than 0. So the graph is basically maximized. Okay, so based on the question given, we have a revenue function negative 2x squared plus 80x. So we have A, B, and C, and A is less than. Okay, for the solution, we need to search for vertex. So formula for vertex is x equal to negative b over 2a, and we substitute the revenue function, and we have 20. So we substitute the 20 into the revenue function, and we have 800. Okay, so for plot the graph, we choose y-intercept when x equal to 0 and y equal to 0. And here the formula for quadratic, which is x equal to negative b plus minus square root b square negative 4ac over 2a. Okay, so for plot, so we substitute the revenue function A, B, and C into the formula quadratic, and we have x equal to 0 and x equal to 14. So we substitute the revenue function A, B, and C into the formula quadratic, and we have x equal to 0 and x equal to 14. So So here the graph that I plot, we have x and y here, and intersection point, which is 20 and 800. Next, we move to case study analysis, which is a topic linear costs and revenue. Next, the question is a company cost function is cost function equal to 40x plus 1000, and its revenue function is revenue function equal to 16x, where x is the number of unit produced and sold. So the question is find the break-even point when cost function equal to revenue function. Next, calculate the profit when x equal to 50, and graph the cost function, revenue function, and the profit region. So the question is find the break-even point when cost function equal to revenue function. Next, calculate the profit when x equal to. Okay, for the solution, we have cost function equal to revenue function. So we arrange them. We have a 40x plus 100 equal to 60x, and the final answer is x equal to 50. Okay, for the solution, we have cost function equal to revenue function. So we arrange them. We have a 40x plus 100 equal. Next, we substitute into the revenue function and cost function. We have revenue function 3000 and cost function is 2000. So to search the profit, we use the formula profit function equal to revenue function minus cost function. So we have 0. Next, we substitute. Here the graph that I already plot, we have x as a number of unit and y cost and revenue. We have the line for cost function and revenue function, and we have loss and profit region here.